In this video, we're going to solve a radical equation that contains two radicals. So here we have the square root of 2x plus 3 minus the square root of x plus 2 is equal to 2. Now the usual procedure for solving a radical equation is to simply isolate the radical and square both sides. So to start with a basic example, say we have the square root of x minus 2 minus 4 is equal to 0. And we isolate the radical. So that means we add 4 to both sides and write this as the square root of x minus 2. Adding 4 to both sides will give us this equation. Now, if we square both sides, we have the radical isolated, so if we square both sides, the left side becomes just x minus 2. Because squaring is the opposite of square root. So squaring the left side removes the radical. Just gives me the radicand, which is x minus 2, and I square the right side. 4 squared is 16. Now we can solve for x now, isolate the x here. We get x is equal to 18. Now it's very important that you check your solution, because when you square both sides, that gives you the possibility of extraneous roots. So in other words, you can get solutions that will work for the squared equation, but not for the original equation. Now this one works. Put 18 there where the x is. 18 minus 2 is 16. The square root of 16 equals 4. This one checks. But notice when if I have say 1 equals to negative 1, that's a false statement. 1 cannot equal to negative 1. But if I square both sides, I get 1, and negative 1 squared is 1. Okay, I get a true statement. What this means is when you square both sides, it's possible that you'll get answers that will work for the squared equation, but not for the original equation. So you always have to go back, check your solution, especially with radical equations. You should always check, but just keep in mind that you could get extraneous roots. Okay. Now, because we'll be squaring, sometimes one side of the equation might have two terms. So here's one for squaring a binomial. A plus b squared is equal to a squared plus 2ab plus b squared. So it's the square of the first term plus twice the product of the two terms in the parentheses, a and b. I got 2ab plus the second term squared, b squared. There's a minus there. Same thing, except you have the minus here. Square the first one, minus twice the product of the two terms, a and b, plus the second term squared. Okay. Now, in this case, we have the square root of 2x plus 3 minus the square root of x plus 2 is equal to 2. Notice it says, note, this may require that you square both sides twice to obtain the solution. Okay? So we're going to pause the video here, and there's your hint for this one, and see if you can solve it, and then I'll come right back. One method I'm going to use here is I'm going to isolate one of the radicals. Since I have two, and in the example I just did, it was one radical, easy to isolate, but here I have two. So I'm going to leave the square root of 2x plus 3 where it's at, and then I'm going to move the second radical over. That means I'm going to add the square root of x plus 2 to both sides. So this side will become 2 plus the square root of x plus 2. Okay, so now I'm going to square both sides. Okay, so this side will be squared. That will eliminate that radical. And then on this right side, I'm going to square both sides. So this side is going to become just 2x plus 3. When I square, it eliminates a radical. So I'm going to put it up here. This becomes a 2x plus 3. Now, on the right side, I'm squaring 2 plus the square root of x plus 2. So using this formula right here, I square the first term. That would be the a here. So 2 squared is 4. And then it's double this product right here. Okay? So 2 times this, and then times 2 again. So this will give me a plus 4. And then times the square root of x plus 2. And then, so the 2 is the a, and the square root of x plus 2 would be the b. Okay, so that means now, for the third term here, I would have to square the square root of x plus 2. And that would just give me x plus 2. Squaring it just eliminates the radical. Now, we collect terms. So let's go ahead and do this. Let's bring the add a minus x to both sides. So, okay, now I'm going to isolate this radical. Okay, add minus x to both sides. That'll cancel this x right here, and then minus x and 2x is x. So I'll put this over here. This will be x. And then 4 and 2 is 6 on the right side. So I take it over to the other side. That becomes a minus 6. Okay, minus 6 and 3 is a minus 3. So then it gives me x minus 3 is equal to, and that gives me 4 square root of x plus 2. Okay, now I've got a radical on the right side. So I just repeat the procedure. Isolate the radical. Now I'm going to leave the 4 just where it is. Because what I'm going to do is this. I'm going to square both sides to get rid of that radical. Square this side, and then square this side. Okay, x minus 3 squared. Okay, just follow this formula right here, a minus b squared. So it's going to be the square of the first term, which is x squared. And then it's minus twice the product, so 3x times 2, that would be, it can be 6x. Okay, now on the right side, when I square this product here, I'm squaring both terms. So the 4 gets squared, that's going to give me 16. And then the radical gets squared, that eliminates the radical, and that becomes just x plus 2. Okay, and I have to multiply by 16. So that's going to give me a 16x on this side plus 32. And then one correction here, here when I square the x minus 3 squared, it's x, the first term squared, got it, minus twice the product, and then of course you got to square the 3 there. So I should have a plus 9 over here. So that's a plus 9. Now, when you do this, of course, in this case, we come up with a quadratic equation. Okay? Sometimes when you just square it once, it might be just a regular linear equation. You solve it and then you check it. Okay? So I'm going to write over here that it's x squared. And then bring the 16x over, or add minus 16x to both sides, so that cancels it on this side. Minus 6 and a minus 6x and a minus 16x is a minus 22x. And then I got 32. I'm going to take it over to the other side. So minus 32 and minus 32, but then on this side I have the 9. So it's a minus 32 and a 9. So this will give me a minus 23. This is equal to 0. Okay. And of course, when solving any quadratic, the first thing you want to do is see if it factors. Okay? One side has to be 0, and then you try to factor the other side. If it doesn't factor, then you can use the quadratic formula or the method of complete the square. Now this one's going to factor into x minus 23 and x plus 1. You can check the product here. X times x is x squared. 1 times the minus 23 is a minus 23 there, and minus 3x, and then 1x is minus 22. So then we just set each factor equal to 0. We set each factor equal to 0. So we get, solve each of those, we get x can be 23. Or x can be -1. Okay, and then you just check those. In some cases, it might be that both solutions will work. In some cases, maybe just one of the other two will work. Maybe in one case, another case, neither one will work. Let's try the -1 first. So let's put a -1 where the x is here. Remember, you always go to the original equation, because if you plug them in the squared equation, it'll probably work there. But you always have to go to the equation you're solving initially. So put a -1 here where the x is. So that'll give me a -2 under this first radical. -2 and 3 is the square root of is 1. The square root of 1 is 1. Okay. And a -1 in the second radical. -1 and 2 is 1. Square root of 1 is 1. I've got 1 minus 1. That's equal to 0. So this one here you reject. This is not a solution. And then you try the 23. So 2 times 23, right here, the first one, 2 times 23 is 46, and 3 gives me 49. That's the square root of 49. And then minus the next one. 23 under this radical, and 2 is 25. This is the square root of 25. The square root of 49 is 7. The square root of 25 is 5. 7 minus 5 is 2. So this one checks. So that's your solution. It doesn't really matter which one you isolate here. Okay. I isolated the first radical, the square root of 2x plus 3. You could isolate the second one. Or you could say, well, why don't we just leave it and square both sides and see how that works. Okay. So let's try this. Let's clear this. So in this one, the answer is x equal to 23. And it checks. Another way to work the same problem would be to leave it the way it is and just square both sides. Okay, let's say, okay, let's do it. And just square the side. And square the other side. Okay, so obviously the square of 2 is 4. We have it here. And then for this one here, okay, it's a and b here, so you square the first term. If you square the first term, that just eliminates the radical. You get 2x plus 3. Okay, 2x plus 3 there. And then twice this product. Okay, so there's a 2, and it's minus, so I bring another minus. And then I multiply the two radicals. Okay, because they're both square roots, I can just multiply them out. So here, what I did here is I said, just go ahead and multiply 2x plus 3 times x plus 2. Multiply the two binomials, and you get 2x squared plus 7x plus 6. And we just put it under one radical. Okay. And then when I square the second term here, the square root of x plus 2, that just gives me the x plus 2 here. Okay? And now what I did is I isolated this radical right here. Okay. So notice this one just came here. And then I have a 2x and an x on the left side. 2x and an x is 3x. Took it over to the other side, so I got this minus 3x here. Okay, and then a 2 and a 3 rather, and a 2 here. 3 and 2 is 5. Took it over to the other side. That's a minus 5 over here. So 4 minus 5 is then that minus 1. There we have it. Okay, so that's how I get this part right here, by combining terms and isolating the radical. And then I go through and then, okay, I'm going to square this side to eliminate the radical. And I'm going to square this side. Okay, so again, the whole thing is squared, so the negative 2 also gets squared. That's the 4. That's how I get this 4 right here. And then, of course, the radical gets squared. That eliminates the radical, but it multiplies the square of negative 2, which is 4. So I have this in parentheses there. And then the square of negative 3x minus 1. You can ignore the negative, because when you can factor out the negative, and that gets squared. So you wind up with 9x squared plus 6x plus 1. And let me clear this now here so we can. Okay. So squaring the two sides, and this is what we got. And then here just multiplied by 4. So 4 times 2x squared is 8x squared. 4 times 7x is 28x. 4 times 6 is 24. Just brought this down. And then I'm just taking these over. I try to simplify this. So the 8x squared goes over, becomes a minus 8x squared. That's how I get this x squared. Minus 8x squared and 9x squared. Take the 28x over, becomes a minus 28x and a 6x. That's how I get the negative 22x. Then bring the 24 over, that's minus 24, and the 1 is a negative 23. And then this is the same thing I got in part 1. Okay? So this again, you just go ahead and repeat the stuff I did in the first case, or the first method. This is x, this factors into x minus 23. X plus 1. And this still equals 0. So you set each factor equal to 0 and solve for x. So this would tell me that x could be 23. Or x can be negative 1. Okay, but as we saw in the first method, the x equal to negative 1 was not a solution, so we have to reject it, where x equal 23 does work. And that's your solution. Thanks for watching. We'll see you next time.